Friends, let's have a look on another interesting question. If vector A, vector B and vector C are three non-coplanar vectors, then the value of box of A cross B, B cross C, C cross A is equal to option A 0, option B box of ABC, option C box of ABC whole square and option D 2 into box of ABC. Okay. So it is a very interesting question. So please listen carefully. Very important with respect to your competitive exams. Okay. So we have box of A cross B, B cross C, C cross A. Clear? So we can assume this A cross B is a vector which is vector P, B cross C is a vector which is Q, and C cross A is another vector which is R. So this will be in the form of box of PQR, and box of PQR is nothing but P dot Q cross R. So applying this concept, we can write this is equal to A cross B dot B cross C cross C cross A. Okay, clear? Understand? Now we have to simplify this part first. So in the next step we can write A cross B dot. Now we know the vector product of three vectors. So applying the vector product of three vectors, here B cross C is one of the vector and another two vectors are C and A. So easily we can simplify this in this way. B cross C dot of A into vector C, okay, minus B cross C dot of C into vector A. Okay, clear? So we apply here the vector product of three vectors. So this is one of the vector B cross C. You can assume this is P. So P cross C cross A is P dot A into C minus P dot C into A, like this. Okay. So let's simplify this. This is A cross B dot, we all know B cross C dot A is nothing but box of ABC. So instead of B cross C dot A, we can write box of ABC. So box of ABC into vector C minus B cross C dot C is box of BCC, which is 0. So 0 into vector A is 0. So we are writing here just the null vector. Okay. So what we have right now, box of ABC is a scalar, so we can put this outside of the product. So this can be written as box of ABC into A cross B dot vector C. Clear? Okay. And A cross B dot vector C is nothing but box of ABC. Okay. So in the next step we can write this is equal to box of ABC into box of ABC. So box of ABC into box of ABC means box of ABC square. So we should write box of ABC square. Okay, so this is the value. So when ABC are three non-coplanar vectors, then box of A cross B, B cross C, C cross A is equal to box of ABC square. Okay, so our correct option is option C. So if it was given in the questions that ABC are three coplanar vector, then box of ABC is equal to 0, then box of A cross B, B cross C, C cross A will be 0 square, that is equal to 0. Okay, so I think you understand the whole concept, and it was an interesting question, is it clear? So please remember the trick and technique, important for your competitive exams. Now come to the next question. So friends, let's have a look on another question. If vector A, vector B, vector C are non-coplanar vectors, then the value of A dot B cross C divided by B dot C cross A plus B dot C cross A divided by C dot A cross B plus C dot B cross A divided by A dot B cross C is equal to option A 0, option B 1, option C 2 and option D none of this. Okay, so look how to solve this numerical. Basically this is an easy question, comparatively easy question. Just you have to understand about the scalar triple product, nothing else. So A dot B cross C divided by B dot C cross A, this is the first part, plus B dot C cross A divided by C dot A cross B, this is the second part, and the third part of the expression is C dot B cross A divided by A dot B cross C. Okay. Now, the numerator of the first part, that is A dot B cross C, is nothing but box of ABC. So we can write box of ABC. Okay. The denominator of the first part, B dot C cross A, is box of BCA, and box of BCA can be directly written as box of ABC. So box of ABC. We know box of ABC is equal to box of BCA is equal to box of CAB. Cyclic orders are maintained. Okay. And when cyclic order does not maintain, then the negative sign will occur. Plus, similarly, the numerator of the second part, that is B dot C cross A, can be written as box of BCA, and box of BCA again can be written as box of ABC. So we are writing box of ABC. Okay. Clear? The denominator of the second part, that is C dot A cross B, is nothing but box of CAB, and box of CAB is nothing but box of ABC. So we are writing box of ABC. Okay. Now come to the third part. The numerator of the third part, C dot B cross A, is box of CBA, and box of CBA can be written as minus of box of ABC, because we need CAB to write box of ABC. Okay, we need CAB, but here it is CBA. So CBA is not a cyclic order. So we should write this as minus of box of ABC. Okay, divided by A dot B cross C, definitely box of ABC. Okay, now let's simplify. Box of ABC, a scalar, and this can be cancelled. So this is 1. Similarly, the second part also 1, but the third part is minus 1. So our answer is 1. Okay, so what is the answer? 1. And the correct option is option B. I think the solution is quite easy. Just you have to understand that what is scalar product, box of ABC, and you have to remember box of ABC is equal to box of BCA is equal to box of CAB. That is the cyclic orders of ABC should maintain. Okay, and when cyclic order does not maintain, then the negative sign will come before box of ABC. Like C dot B cross A, here cyclic order does not maintain, because to maintain the cyclic order CAB were required. So C dot A cross B is box of ABC, but C dot B cross A is minus box of ABC. Okay, I think it is clear. Understand? Interesting. Sure. Now come to the next question. So friends, let's have a look on another interesting question. If vector A, vector B, vector C are coplanar vectors, then the value of the determinant, the first row is vector A, vector B, vector C. The second row is A dot A dot B, A dot C, and the third row is A dot B, B dot B, B dot C is equal to option A 0, option B 1, option C any real value except 0, that is non-zero real value, option D none of this. Now look how to solve this numerical. Very interesting question. So as A, B, C are coplanar vectors, so definitely they are linearly dependent vectors. Okay, so as A, B, C are coplanar, so vector A, B, C are linearly dependent vectors. Okay. So as ABC are linearly dependent vectors, so we can choose three scalar x, y and z. So if x, y, z are three scalar, we can say x into vector A plus y into vector B plus z into vector C is equal to null vector. So therefore for three scalars x, y and z, so here x, y, z are not variables, scalars, or you can consider alpha, beta and gamma, three scalars. X into vector A plus y into vector B plus z into vector C is equal to null vector. Okay, clear? Now look in the second row of the determinant A dot A dot B, A dot C, just we can take the dot product with A, B, C. Okay, that is, if we take the dot product with the first row, we get the second row. And if we take the dot product by B with the first row, we get the third row. So taking dot product by A with the first row, that is with this system. Okay, so taking dot product by A, what we will get? X into A dot A, y into A dot B plus z into A dot C is equal to A dot 0, that is equal to 0. Okay. And also if we take the dot product with this system, that is xa plus yb plus zc by b, then we'll get x into A dot B plus y into B dot B plus z into B dot C is equal to 0. Sure? Okay. So if we give this is number 1, we can write here taking dot product by vector A in 1. Okay, so we get this line, and in this step what we done? Taking dot product by vector B in the both side of 1. Okay, clear? So till this step, what we done? As ABC are coplanar vectors, so definitely they are linearly dependent vectors. So if we choose three scalars x, y and z, we can easily say x into vector A plus y into vector B plus z into vector C is equal to 0. And we give this is equation number 1, and this condition arises as ABC are linearly dependent vectors. Every linearly dependent vectors are coplanar vectors, we know. Now we take dot product A in both sides of 1. Okay, we get these steps, that is, if we give these steps as number 2, so this is number 2. And if we take dot product by B with both sides of 1, we get this step. Okay, so give this is number 3, equation number 3. So we have three equations, which is a system of homogeneous equations because right hand sides are 0. Okay, so if we eliminate x, y, z from these homogeneous systems of equations, we get this value. Okay, so eliminating x, y, z from this homogeneous system of equations, we get determinants of A, B, C, okay, A dot A, A dot B, A dot C, A dot C, and the third row A dot B, B dot B, B dot C. So A dot B, B dot B, B dot C. Okay, and this must be 0 as this is a homogeneous systems of equation. So the value of these given determinants is equal to 0. Okay, and our correct option is option A. So I think you understand the whole concept. It is very simply, as ABC are coplanar vectors, so they must be linearly dependent vectors, and when they are linearly dependent vectors, then if we choose three scalars x, y, z, we can write xa plus yb plus zc is equal to 0. Okay, which is linearly combined vector, and the result of this linear combinations is equal to 0, and all x, y, z are non-zero definitely. And we give this is equation 1. Just taking dot product by A in both sides of equation 1, we'll get the equation 2, that is x into A dot A plus y into B dot A plus z into C dot A is equal to 0, which is equation 2. And taking dot product by B in both sides of equation 1, we get the equation 3, that is x into A dot B plus y into B dot B plus z into C dot B is equal to 0. Okay. Now, as equation 1, 2 and 3 form are homogeneous systems of equations, so just eliminating the scalars x, y, z, we can write determinants of A, B, C, A dot A dot B, A dot C, and the third row A dot B, B dot B, B dot C, okay, is equal to 0. Why 0? Because it is a system of homogeneous equations. Right hand sides are 0 for every equations of the systems. Okay, clear? So in this way we can solve this numerical. I think the solution is quite interesting. Is it? Okay, clear your conception? Now come to the next question. So friends, let's have a look on another questions on vector. Let vector A equal to 2i cap plus j cap minus 2k cap, vector B equal to I cap plus j cap. Vector C is a vector such that A dot C equal to mod of vector C, mod of C minus A vector equal to 2 root 2, and the angle between A cross B and vector C is 30 degree. Then we have to find mod of A cross B cross C. Options are given in the board. Option A 2 by 3, option B 3 by 2, option C 2 and option D 3. Okay. The question is very important with respect to your competitive exams, and method of solution is also interesting. So listen carefully. So we have to find, finally we have to find what? We have to find A cross B cross C mod. Sure, we have to find this. Now, A cross B is a vector and C is another vector. So mod of A cross B cross C can be written as mod of A cross B into mod of C into sine of angle between the vector A cross B and C. And in the question it is given the angle between A cross B and C is 30 degree. So we can write this is sine of 30 degree. Sure. And sine of 30 degree is nothing but half, we know. So now we need to find what is the value of mod of A cross B and what is the value of mod C. To do this, look, we have mod of C minus A as 2 root 2. So we have mod of C minus A is equal to 2 root 2. Sure. So if we make square, so this is 2 root 2 whole square, that is nothing but 8. Now, if we apply the formula mod of C minus A whole square, this will be mod of C square plus mod of A square minus 2 into C dot A. Okay, this equal to 8. Now, we need to find mod of C from here, because as the vector A is given as 2i cap plus j cap minus 2k cap, easily we can find mod of A, which is square root of 2 square plus 1 square plus 2 square. Okay, so instead of mod of C square, we are writing mod of C square, and instead of mod of A square, we are writing, as vector A is 2i cap plus j cap minus 2k cap, so this is 2 square plus 1 square plus minus 2 square. Okay, so this is mod of A square, and also it is given C dot A. We know C dot A is equal to A dot C, as dot products is commutative. So C dot A is equal to A dot C, which is nothing but mod C. So instead of C dot A, we can write mod C. So this is minus 2 into mod C equal to 8. Okay. So what we'll get? We'll get mod C square plus 448 plus 1 9. Shift this 8 at the left hand side. We'll get 1 minus 2 mod C is 0. So minus 2 mod C is equal to 0. So this is a perfect quadratic equation of mod of C. From this equation easily we get mod C. So in the next line we can write mod of C minus 1 whole square is equal to 0, which gives the value of mod C equal to 1. So one of the important value, that is mod C equal to 1, we already get. We require this, okay, to find this value. So now our intention to find mod of A cross B. Now how we can find this mod of A cross B quickly? Look. We have A and B, so directly we can find A cross B, and then we can take mod of A cross B. And little bit easier method is, first of all we can find A dot B. So also we can write vector A dot vector B is equal to 2 dot 1, that is 2 into 1 plus 1 into 1 and minus 2 into 0 as no k in vector B. So minus 2 into 0. Sure. So A dot B is nothing but 2 plus 1, that is 3. Okay. Now we all know mod of A dot B square plus mod of A cross B square is equal to mod A square into mod B square. This is the formula which we already discussed in our theoretical portion, is it? So we can write this as mod of vector A square into mod of vector B square. Sure. Already we find A dot B as 3. So instead of mod of A dot B square, we can write 9. So 9 plus of mod of A cross B square is equal to the value of mod A square is 2 square plus 1 square plus 2 square, that is nothing but 9. And the value of mod B square will be 1 square plus 1 square, that is nothing but 2. Okay. So what is the value of mod of A cross B square? It is 9, because this is 18 and we can shift this 9 at the right hand side. So this is 9. So what is the value of mod of A cross B? It is 3. So mod of A cross B we get as 3. So we have value mod of A cross B as 3 and we have mod of C is equal to 1. Sure. And the angle between A cross B and C we have 30 degree. So the value we have to find now, mod of A cross B cross C, that is mod of A cross B into mod of C into sine of 30 degree, because angle between A cross B and C is 30 degree. We already find mod of A cross B as 3. So just put 3. We already find mod of C equal to 1. So this is 1 and sine of 30 degree we know equal to half. So half. Sure. So what is the answer? 3 by 2. So in this way we can easily solve this numerical. I think the method of solution is quite interesting, important for your exam. So please remember the trick and technique. Okay, understand? I think you clear your concept. Okay.